All right, so if we have a repeating decimal and you're asked to write this as a fraction, what you do is you use that infinite sum formula. So what is that infinite sum formula? Well, it's the sum of an infinite number of terms equals t1 over 1 minus r. And we can find a sum if the series is convergent. Remember, there's a sum. You can find an actual sum of an infinite number of numbers if the numbers are getting smaller each time, because eventually you're going to be adding pretty much 0. So you're going to be able to have a sum. If it's divergent, it doesn't count. Now, what is the list of numbers here? This is the tricky part. So we did an example like this already, and what I suggested was that you start with the first number that repeats. So I'm going to start with 0.7, okay? And because 7 repeats each time, I can break this decimal up into parts like this. If I take 0.7 and I want to add this 7 on there, notice that this is 0.07 that I would add to get 0.77. So I would add 0.07 to tack on this 7. If I wanted to tack on this other 7, I would add 0.007. 007. If I wanted to add another one, it would be 0.0007. And guess what? I am going to show this as an infinite sum because this repeats forever. This process, if it's repeated forever, it will equal this repeated decimal. So we have our series laid out, and I'm going to use that infinite sum formula because it's written in the form of a ratio here. So if I could plug some values in and simplify a ratio without converting it back to a decimal, why would I do that? But I could leave it as a ratio and I would end up with a fraction. So let's do it. The sum formula, okay, shows that T1 in my list is 0.7. 0.7. And this is a really simple formula, isn't it? 1 minus, now what's the R? Well, if you took 0.07, divided it by 0.7, as we found in an earlier example, this gives us 0.1. So we multiply by 1/10 each time to get the next one, okay? And so we have minus 0.1. And this turns out to be 0.7 over 1 minus 0.1 is 0.9. Okay. Now, you wouldn't want to just get on your calculator and divide this and get a decimal because we'll get the original decimal. Okay. And you can check that out if you want. But what we want to do is we want to simplify this into a fraction in lowest terms. And of course, if I multiply by 10, the top and the bottom, I get 7 over 9. Now, this basically what this is saying is that our repeated decimal, right here that we started with, if you consider this decimal as a sum, the sum will equal 7 over 9. And that, my friends, is how you get the equivalent fraction for a repeated decimal. There's your equivalent fraction, 7 over 9. So 0.7 repeating equals 7 over 9. And we can confirm that on the calculator. So we're going to turn this puppy on. And there's my 0.9 repeating equals 1. Okay, calculator is helping me out with that one. And so if I did 7 divided by 9, I get 0.77 repeating. The calculator rounds the final decimal here. Okay, so 0.7 repeating. Hey, interesting note. Interesting note. Whatever number you put divided by 9 gives that number repeated. 0.4 repeating. What about 5 divided by 9? Guess what? That's 0.5 repeating. Okay. It doesn't work for numbers greater than 9, but there are other patterns that you can explore. So that's that one. Now this one is another question that I would like you to try right now. So pause the video, or right now, if you're in my class learning this right now, I'm going to pause here and I want you to give this a try. Okay. Take this concept and take the infinite sum formula, which I will rewrite here for you. Infinite sum is T1 divided by 1 minus R, where R, it's between -1 and 1, right? Or the absolute value of R is less than 1. Okay, so it just means that it has to be convergent. That's what this all means here. So go ahead and give that a try. All right, so hopefully you've had a chance to take a look at this, and I'm going to go over the answer here with you. So if you've had a chance to do this, you can look up on the screen here and see if your answer agrees with mine. But what we want to do is we want to write out just a few numbers in this series, just so we can understand kind of what T1 is and how and what R looks like. And so the part that's repeating is the 0.54 part, right? It's 0.54, 54, 54, 54. That's the part that's repeating. So the first term is going to be 0.54. What we're going to add to that to get to tack on the next repeated part is 0.0054, then 0.000054. That's how we start to add these together to start to build this repeated decimal. So T1 is 0.54 and R is actually 0.01. All right, easy. 0.54 divided by 1 minus 0.01 gives us 0.54 divided by 0.99. And so if we multiply both sides by 100 and divide both sides by 9, or top and bottom by 9, then we get a simplified fraction of 6 over 11. So this repeated decimal is equal to 6 over 11. Now remember, when we talked about rational numbers before in class, rational numbers are any numbers that can be written as a ratio of two integers. And a rational number shows up as either a terminating or repeating decimal. So those were the keys to know if you had a rational number. 6 over 11 we know is a rational number. 0.54 repeating we know is a rational number because it's a repeating decimal. And here now we've connected the two. So before, that was just an indication and you were told, hey, if it looks like this as a decimal, it's going to be rational. But now we can prove it. And so here you go. So that's an important skill here, writing a repeated decimal as a fraction using the infinite sum formula.